All right. Welcome back, everyone. In part two of our lecture, we're going to start talking about request. We're going to start talking about asynchronous. What is asynchronous? Axios. What is Axios? We'll then break down a promise, why promises are asynchronous. We'll talk about .then versus async and adding a card. Now, the point of this project or this React project is we're going to go ahead and interact with the Poke API. We're going to fetch details of a Pokemon. And then we're going to go ahead and render it on the screen. So we're going to do a little bit of screen setup here. First, I'm going to remove all of my CSS information because we don't need any of this. All right. That's going to NTI my project. If my development server was running, that would be a thing. There you go. All right. And there's what my current development server looks like. All right, we can see this is staying blue because currently I'm using some inline styling to do so. All right. I'm just going to name this Corsair Pokemon project. And from here, let's go ahead and generate a form. This form will take the input of type text. It will have an ID, or excuse me, a name of Pokemon name, a placeholder of Pikachu, and we'll go ahead and close this input field here. And then finally, we'll add an input type submit. With a value of search. And there's my input form right there. Right? I'm going to be able to type something in, be able to look up a Pokemon, and a Pokemon should render. Now let's go ahead and write some JavaScript code that will handle this information. We're going to go ahead and do this handle submit, which is going to take in an event. Again, we'll go ahead and prevent default. We learned this yesterday with working with forms. And we could grab our data. So data, make this object dot from entries. And this from entries is going to take a new instance of form data, which should take event dot target. Now let's go ahead and just console log data. Okay, finally, we're going to go ahead and pass this on to our handle submit. Notice how when I'm typing this on submit function, it is now following the camel case convention. And before, when we were calling a function, we're actually calling it like this, handle submit, and we will pass in the event. This is going to cause an error in React. If you're calling a function, you're actually not going to pass in the opening and closing parentheses. Because in this case, it's going to wait for the event of onSubmit to call the function. Now, because we are passing parameters into this event, instead, we're going to provide an arrow function that will call our handle submit function with the event. All right. I'm seeing that line through. We're seeing that event is deprecated. Declaration was marked as deprecated here, which is okay. We don't have to worry about that for now. All right, let's go ahead and take a look at our console and see where we're at now. I'm going to refresh the page. Going to provide Pikachu. And there I get my Pokemon name of Pikachu. So everything in my handle submit data is working as expected. We're actually able to grab the data to be able to display our information. Finally, I'm going to go ahead and create a container. And inside of that container, I'm going to generate a card. So now I can go ahead and make a new function here. Const generate card. Now this generate card is going to take in a name. And what it's going to do is one, it's going to grab the container. So let container be equal to document dot query selector. We're looking for the ID of container. I am then going to create a division. This is all information that we learned yesterday. So this should look like a review. And for this division, I'm going to go ahead and add a paragraph and image tag. So let's go ahead and call it an H3, be equal to document dot create element. Let's pass in an H3. Let img be equal to document dot and actually let's grab data instead. Be equal to create element, which is going to create an image. Now, currently we don't have an image source, which is okay. But we're going to go ahead and grab the name. I'm going to say h3 dot inner text is equal to data. And we'll pass this in as name. We'll then grab our div and append the following children. Where the first child that we're going to append will be the image. And the second child that we will be appending will be our h3 tag. Finally, we could go ahead and add it to our container. Now this div here, I am going to also give it a class of card. So I'm going to go ahead and say div.class name be equal to card. And let's go ahead and add some CSS here. We have our card, which I'm going to do display flex. Flex direction of column, and then justify content center. I think that should do it. All right, so now I have this generate card function that I have to add here. Currently, I have my data, where my data just comes up as Pokemon name, Pikachu. But I'm expecting the keyword of name. So maybe I could change that inside of my in my app.jsx. So instead of Pokemon name, this is known as name. Now we can go ahead and add it. We can say generate card. And let's go ahead and do so here, where we pass in data. I refresh the page, there's no errors. I'm gonna pass in Pikachu, and then Pikachu shows up. Nice. I'm not seeing my broken image source. It could be because I never provided one. So let's go ahead and do it this way. There you go. And now we can see them showing up. Great. All right. All of this should have been review, but let me go ahead and break this portion down because it is important for us to understand what's going on here before we start diving into the next part of our lecture. Currently, we have an H1 element that holds a form. This form has an onSubmit event called handleSubmit that is accepting our event. When handleSubmit is called, we want to prevent the default behavior of a form because a form will try to refresh my browser. We don't want that. All right, so we stop it from refreshing. We're going to capture the data from our form. I'm logging onto the console the data so I can ensure that I'm capturing it correctly. And then I'm triggering this generate card function. The generate card function is grabbing the container. We can see this container down here. I grab the container. After grabbing the container, I generate a division class, or excuse me, a division element with the class name of card. This division element will accept both an image and an H3, where the image source is unknown and the H3 text is of name. We're then going to append our children so that they show up properly. All right. Before I continue on with how we're going to grab this data from the Poke API, does anyone have any questions over this generate card function or this handle submit function? All right, I'm also not seeing anything in the Corsair questions, so hopefully this was a pretty good breakdown and we all understand this block of code. Again, if at any point we want to review this block of code, please let me know. So now we're able to capture all of our Pokemon information, or at least capture the user input so that we can grab data. But now we're going into the second portion of our application. Our application is rendering static files. But in our full stack development, let me find my picture because it ran away from me. Here we go. In my full stack development, we can see that static files don't generate all of the functionality for my site. I also need to be able to interact with an API. Now today, we're going to be interacting with the Poke API. And we could take a look at the Poke API documentation here. I'm going to go ahead and share this in Corsair questions. So if anybody wants to take a look, you can. Now, it gives me a really nice playground that I can utilize to interact with this information. If I wanted to grab all the information regarding Pikachu, I could definitely do so as such. And all of the static files regarding Pikachu would show up. For example, if I wanted to hear the cries, here's some data for cries. But as of right now, what I really need is the image. All right. Well, there's the sprites that's provided for us. And sprites currently gives me something called front default. And I could come here and generate front default. All right, that's the little image of Pikachu that I'm trying to find right now. All right. Now, there's even some shiny images, which are pretty cool. I've seen people grab this Poke API for their final projects and make an entire catch a Pokemon emulator where you're running around in grass and then randomly a Pokemon will show up and you have to catch it. It's really cool. If you're interested in games and you're a Pokemon fan, I strongly recommend this API. And it's very well maintained. All right. Now, with that said, something else that's really important about APIs, or whenever you're choosing an API, is actually reading their API documentation. And here I can click on API version 2 because they are on version 2 of their API. And they have all their documentation for different things that you can look up. So for example, they have resource. And you can look up things in list and paginations. So for example, if I wanted to look up abilities, I could just grab the top 20 abilities that are available in there. All right, I could do something similar with Pokemon. And you can see that it stops at endpoint. Well, let's take a look here. All right, I come over, I take off Pokemon, and when I look up just Pokemon without any sort of limitation, by default, it's bringing back 20 items and it's giving me the first 20 Pokemon that are available to it. It's a nice interface and something really cool that you can use in case you want to grab the top 20 Pokemon for something. Additionally, in their API documentation, if I scroll down, they have an entire Slack community to be able to interact with other people through other people through Slack. They talk to you about the different libraries that they're using to maintain their information. Funnily enough, this API was originally built with the same exact tech stack that you're learning here in Code Platoon. And it has now outgrown the tech stack that we teach, and it's now on different. You can see that now it's a Ruby on Rails, I think, application. All right. It goes into different information here. We can take a look at berries, different berries that are attached to the Pokemon API. There's contests, encounters that could be found. So there's an encounter method and then ID or name. You could find it, how you could find those different encounter methods. Evolutions are also available along with evolution triggers. Games where specific Pokemon are found. Uh, Pokédexes. If you're interested in just making a Pokédex simulator, this is actually really useful. Um, some items, locations, and of course, there's Pokemons. Now, Pokemons fall into different varieties, right? We could find them by abilities. We could find Pokemons by egg groups. Um, if you're not a Pokemon person, I know this is all just probably gibberish to you, so I do apologize. But something really important to also know is types, right? So you can filter Pokemon by different types of information. Now, this API is very friendly and easily readable. Believe it or not, that is not the case for the majority of APIs, unfortunately. One of the biggest friction points that you'll find in your development career is finding good APIs to interact with that have well-structured documentation. Now, the trick about documentation is that you want it to be specific enough to where it's guiding for a developer to adapt it to their code base, but not so specific that it's constraining for the developer to adapt it to their code base. Right. So finding the middle ground is very hard, especially talking from the API creation side. But at the same time, some elbow grease is necessary in order to make your API applicable. Now, APIs that become really well known and famous, they usually have some of the worst documentation that you can find. And that's on purpose because they expect you to be experienced and have the ability to adapt their API into your code base. All right. So now I've explored this API. And the goal of being able to interact with this API would be able to look up something like Pikachu and return this JSON data. I can copy this to my clipboard, come here, and run it. Right? I want this entire JSON body to be demonstrated inside of my React application. Well, how do I do that? How can I facilitate requests? Right? Because I am requesting information from a server for my front end application. If I go back to my drawing here, we're talking about the portion of interacting with an API to grab our data. We're going to do this by grabbing Axios. Now we're learning a lot of new installments today. And this is good, right? Today's our introductory day. We're going to be using this information later on. There you go, getting started with Axios. Um, so today's just more of a, hey, what are all the tools that I need to make a good static site? And Axios can be very vital for making requests. We're not going to start talking about interceptors in this lecture, but we will talk about interceptors later on and what that is. For now, just keep that in the back of your mind. But we're going to utilize Axios to essentially send a request of information. Now, we talked about HTTP methods before. And we can see here that we have our HTTP methods of get, put, post, and delete. Now, for these HTTP methods, which one of them is for reading information? Because they correlate to their CRUD capabilities, right? Where their CRUD capabilities are read, create, update, delete. So which HTTP method grabs information so I can read it?
Get.
Get, right? So I know that when I build this function, I want to send a get request to the Poke API. Now, when I'm sending this get request to the Poke API, what's the URL that I want to use? Where is it that I'm requesting information from?
From like the direct URL before, the little stinger or whatever it's called.
Got it. So if we come over to the Poke API, this is
Sprites,
the
not
URL.
not. Oh, okay. I thought it was sprites.
Yeah, and we're gonna eventually get it from
Okay.
sprites, yeah. But this is the URL that we're looking for, right? Now, we saw the JSON data being returned from this endpoint. This is the JSON data that I'm requesting. So I'm going to grab this URL and specify that I want to utilize this URL to grab information. Now, is this the correct URL that I want to utilize? Am I always going to be looking for Pikachu? Okay, so I see Erica nodding no. So we're possibly looking for different Pokemon. So how could I make this dynamic? Right? If this URL pattern was a type of string and I'm setting it equal to something, what kind of string would this be created as? Do we want backticks? Do we want triple quotes? What kind of string would allow me to insert a value?
An F string.
Okay, so an F string, awesome. So you're thinking about string interpolation, right? And in order to conduct string interpolation in JavaScript, what we're looking for is backticks, right? And then here we would do a name for the Pokemon, all right, which we know we are capturing here. All right, so we're going to request for this data. And when we have this data back in our hands, we can then render a card into our container. Well, let's start building this function. And I'm going to actually move this whole body up so that it exists up here. All right, let's start talking about this request. So I'm going to const get Pokemon data. This function is going to send a GET request from the Poke API. But how are we supposed to send this GET request? Well, let's see. I know that I also want to capture the name of the Pokemon. All right. We can make our URL, right? And we can do so like this. Request URL. You probably want to utilize let there so that it's actually identifiable. So then we have our request URL, which we created. This is where we're going to make our request from. And we analyze that we want to make a GET request. Well, how? This is where Axios comes in. This will allow us to handle promises. What is a promise, right? Well, let's talk about this. I'm going to go ahead and npm install Axios. And you can see that Axios has been installed. Now, not only am I seeing it in my terminal, I could check package.json. And if I look into dependencies, I am now seeing Axios added in my dependencies. So it tells me that it's been installed properly. Well, how do I use Axios. First, I have to import it. So I have to say import Axios from Axios. And you can see that this imports Axios for me. And Axios is a tool that will allow me to make requests. Well, that tells me that I can say Axios dot get. And when I send my get request, you can see here that it's asking for an attribute. It's telling me, hey, where do you want me to send a get request to? So Axios is a class that has a method named get, and I am sending the attribute of request URL as a parameter there. Well, let's go ahead and see what happens when I console.log this information. And currently I am not calling this Pokemon data, so let's go ahead and do that really quick. Let's do get Pokemon data. I'm actually going to comment these two out. Oh, I apologize, everybody. Let me get back to that. Thank you. All right, we're going to send it to get Pokemon data, where we're going to pass in data name. All right. I go ahead and put Pikachu, and I get an error. So it's getting a connection refused. Interesting. And that's happening because I'm not running my development server. So let me run dev one more time, refresh it. We come down to Pikachu, and I'm getting this promise. It's telling me, hey, it's been pending. It does eventually become fulfilled. And when it becomes fulfilled, I get back this data attribute. And in that data attribute is all of the information that belongs to Pikachu, right? That one JSON object that we're seeing here is now in my promise. Well, what is a promise? Right. So this dot get method returns a promise, where a promise is, I promise I will get back to you as soon as possible. And this promise that they'll get back to us as soon as possible is coming from the server. So let's start talking about how that's coming in from the server. And come over to this drawing here, and we're going to scroll down a bit. So we're going to start talking about the server side information here. So the server gets an incoming request as of right now. And this incoming request is stating, I need information for Pikachu. And I need it sooner rather than later. Well, the server responds with a promise saying, give me a sec. I'll get back to you. Right? Dot then is generating this promise because it's waiting for the server to get back with a response. Right? Okay, so we generate the request. Oh, excuse me, I said dot then. I meant to say dot get. This dot get is saying, all right, give me a second. I'll get right back to you as soon as I get a response. Well, when the server gets this request, it needs time. It needs time because it needs to query the database, right? Which may look something like select all from Pokemon table where name is equal to Pikachu. And let me go ahead and move this a bit because I know you guys can't see that very well. Right? So it says select all from Pokemon where name is equal to Pikachu. All right, so that's handling the database. But now, outside of the database, I need time to serialize this information because from the server side, depending on what language it was written, when that query comes back, it comes back as an instance of the class query set. All right, so it's just query set where memory location is at 1, 2, 3, et cetera, et cetera. But right. Well, we need time to turn that into an object that holds name, that holds sprites, that holds price, and all of the other crazy information that is coming back from our server, or that is coming back as a response. And then finally, once it serializes everything, I also need time to generate and send a response. I can spell. There you go. And this is where we typically get a return response with JSON object and a status, right? So the server is not just it's not just something magical. It needs time to be able to conduct all these operations. And that's where the promise comes into play. All right, when Axios sends a GET request, remember, JavaScript is a runtime language, meaning that it's simply just going from top to bottom. If I try to access any value inside of that request before the server is done calculating all this information, what would happen? A guess works.
You get an error.
Yeah, I would get an error, whether it's going to tell me it's undefined or this property doesn't exist. And I'm getting that error because none of this on the right-hand side, on my server side, has been completed yet. So that's where this promise comes into play. Once I have my response, my server will respond with a JSON object. And when that response comes back, this will also resolve the promise, making the promise fulfilled. All right. Well, how do we handle that in JavaScript? Because as of now, all I'm seeing when I run my code, I apologize, wrong tab. Let me go ahead and inspect this. All I'm seeing when I run my code is a promise being generated. It does tell me that it's eventually fulfilled, but how do I work with it? Well, let's see. If I try to do something along the lines of let promise be equal to so and so, and then I can go ahead and do promise dot object. It looks like that's what it's called. Well, let's just try to do object dot name because according to the Poke API, that is something that is applicable, right? If I take a look at all these key value pairs, there is, oh, clicked on the wrong thing, a name parameter. This name key would return the value of Pikachu. So technically this would work, right? Let's go ahead and run that. Let's do console.log, and now come over to the React application. I'm gonna refresh it, come over to Pikachu, and I search. Well, it's giving me undefined. That's because, again, I try to access the promise before it's been fulfilled or resolved. So I need to find a way to tell Axios or tell JavaScript, you need to wait before running this logic. And well, how do I do that? We do that utilizing the .then method, where the .then method takes in a function. In this case, what we're grabbing here is the response from the server, and then we can do some information with that response. Well, let's console.log response now. Now, when we take a look at response, we actually have the headers of the response, the status in which it was completed, and more importantly, we have the data that is coming back. This is when we are working with JavaScript and making requests. We're simply pausing. Then is telling JavaScript, I know you're trying to run. I understand that you have an urgency to read all of this code, but you need to wait because we need this promise to be fulfilled before you continue executing this body. All right. Once the promise is fulfilled and I have the information for you, please execute the following code. Does anyone have any questions over Axios or .then?
Yeah, sorry. It's obviously a lot like I just feel like pivoting from Python to this, it's just so many more moving parts, it seems like, at least for somebody myself. For Axios itself, that is just done when you do the dev environment, as far as like, or how do you get Axios again? I forget.
Yeah, we actually installed Axios manually. We did it inside of our terminal. We
Okay.
canceled our development server and then we ran npm install Axios. And
Okay.
then that added it as a development dependency.
Okay, cool. Thank you.
Of course. All right. Any other questions?
Are you chaining that dot then to the end of the Axios line, or is that its own thing?
Yeah, it's a great question. So it is chained, right? I know that there's a space here. But this dot then is a specific property that is looking for a promise to resolve. This dot get generates the promise, so dot then resolves said promise. Does that answer
Gotcha.
your question?
Yes. And then the response that you passed in to the function, oh, that's just the promise, right? That's like a value. Like, is that a keyword or
No,
or is it just a value? You could name it anything.
it's just a value. We can name it anything. So if we change it for X, we could search it and it would still work the same.
Gotcha. And that's representing the promise.
That's representing the resolved state of the promise, which would be the response.
Okay, gotcha. Thank you.
Of course. Any other questions? Okay, so we're waiting for this response to come back. We finally get the response. And now that we have the response, we can actually generate a card, right? Where we could pass in data. So now this console.log, we could grab data, or we could say generate card that takes in response.data, right? Because .data is an attribute of the response or a key of the response. This is a dictionary at this point, or excuse me, an object at this point. So now when I click on Pikachu, we can see that Pikachu is starting to be generated. Great. We never hard coded that value into my generate card. It's just grabbing data name. Well, for the image source, we know that there is data. If I take a look at data, I think earlier you mentioned that we would want to go into sprites, and that was Brandon that mentioned that. So let's go ahead and look for a key of sprites. Okay, so here's my key of sprites. I'm gonna write that in there. What would be the next key that I want to access? And I'm gonna pass this one off to Jake.
Mm, Still thinking.
Sorry, could you say that one more time?
Yeah, I'm still thinking.
Yeah, no problem.
Lots.
Yeah, as of now, we're grabbing data and going into sprites. So this here is our entire data body. We're within sprites, which is an object of 10 keys, and these are the keys that are available. So what's the next key that would want to enter here?
I don't know.
Okay, awesome. Let's go ahead and pass this one off. Let's pass it off to one of our TAs. Let's see, let's hear from Elia.
I think we should do one of the shiny ones.
All right, let's do one of the shiny ones. Let's try front shiny. Let's see that. We're gonna go ahead and run front shiny. All right. Let's take a look at our application now. You'll probably want to delete all of that. There you go. Gonna refresh this application. I'm gonna come over to Pikachu and click search. And now Pikachu populates as such. All right, we can get Pikachu showing up. Now it's just a matter of CSS here. Let's go into our app CSS and let's fix this card. Put justified content, which it should actually be line items. Um, there you go. So there's my card with the align item center. Let's give it a height and width. So let's give it a height of 30 VMin. Let's give it a width of 15 VMin to make it more of a card. Let's give it a border of 1 VMin, solid and black. Let's go ahead and continue on here by making it max height, being fit content. There you go. I made it a little smaller. I think we should give it some border radius to give it some rounded edges. There you go. And now we have our Pikachu card. Now, if I wanted to look up Bulbasaur or Blastoise, Blastoise shows up with my front shiny. All right, let's say Mew. Mew also shows up. Uh, I could think of another one. There you go. And there's Charizard. All right, so we can see how each one of our cards are being generated, all from the Poke API. Now, how's this happening? Let's talk about this. First, we're handling the submission of our form. Our form is preventing the default behavior where we're refreshing the page. Then we're creating a dictionary from our form where we're grabbing the key of name and passing it into the get Pokemon data function. The get Pokemon data function is using the Poke API. So we grab this URL parameter, which we grab straight from the Poke API documentation right here. That tells me how to interact with Pokemon. The information that I want to grab will be of Pikachu, which is being passed in as a parameter, the name of the Pokemon. And then I'm going to make a request to the Poke API to the Poke API for said information. In order to make this request, I utilize Axios. It's running a GET request because I want to read. Right? So GET request because I want to read. That then brings up our server communication. A GET request comes in and a promise is generated. My server needs time to conduct all of its actions before it can come up with a JSON readable response. So we need to tell JavaScript to stop and wait for this response. So we utilize .then. .then captures the resolved promise, which is the response object that comes from the server. We can console.log the response, and then we pass our information to generate card. Once the data goes to generate card, in generate card, we utilize the information from the Poke API. There's a couple of creation of we grab a container, we create a div, we give it a class, we create an H3, and we create an image. Our image source is looking at data, where this is our entire data object being mapped out from us down below. All right, if I scroll up, here are all the abilities and everything else that's coming inside of data. Why specifically want an image? So we're going to go ahead and dive into sprites. So we talked about data maps here. We dove into sprites, where sprites maps in here. And then finally, we grab front shiny, where front shiny is coming from here. This then turns into the following URL pattern. All right, so the response that we're setting here looks as such. That's what we're setting as the image source. And we do the same thing with our name tag. Again, this is the entire data. We're grabbing inner text and we're saying data is equal to the name. And if we scroll up here, we can see that name shows up in our data object. All right, so the value of name becomes Pikachu. Finally, we append both of these image and H3s into the division that we had created. And then we add it to our container. And that's how our get data or our generate data works, right? So Pikachu, I can go ahead and run Bulbasaur, and my Bulbasaur shows up. I think it's with the, oh, there you go. All right. Does anyone have any questions over how we were able to grab data from the Poke API and utilize Axios to make requests?
Not the grabbing of it, but is sprites like a universal term, or is that like a Pokemon term? Like, would this be is sprites used across the board for all APIs?
That's a great question. And the answer is neither. Sprites is not common across the board for all APIs, and it's not a Pokemon term. Sprites is another way of referencing to images. It is more common that you'll see something labeled as images,
Oh, okay, cool. Thank you.
of course. All right. Any other questions?
And not all APIs return images or things like that either. APIs can communicate any kind of information. So it's one where you would have to look at the documentation for the API and see specifically if they're sending you back images and what they're calling them.
Awesome. All right. Now, what happens when I make a request that can't be resolved? For example, my user makes a mistake and they put nothing into the form. Well, now my GET request comes back with 404 not found. Now, this 404 is being created by the server that I am making a request from. So the 404 error is coming from the Poke API. And it's stating, hey, I don't know what Pokemon you're looking for because according to you, the Pokemon you're looking for is Huyak, whatever that's supposed to spell, right? And that doesn't exist inside of my database. Okay, awesome. Well, how do I handle that on the user side? I could get a console.log error, but there's got to be something else that I could do here. All right. Well, what I can do is I can actually catch the error. And here, one, we could console.error, the error that's coming in. So now if I refresh it, I put some gibberish. The error is actually being handled. And we're console.logging the error. And we could also alert the user of Pokemon doesn't exist. I think I'm doing this part wrong. There's my Pokemon doesn't exist. Nice. All right. So now the user actually knows that there's something going on and that their error isn't being handled correctly. Right? This is called a try and catch. Well, in this case, there's no try, but this will catch the failure of a promise. All right. Does anyone have any questions over the catch block? Okay. Now, this request here is an example of an asynchronous function. Now, what is asynchronous? Now that we've seen it in action, we could break it down a little bit. All right, so there's synchronous information that is happening, or actually asynchronous information that is happening, and then synchronous. So synchronous would be something like having a conversation. When you're talking to somebody, you would typically wait until they're done completing their functionality or being done talking, speaking, before you can go ahead and respond to them, right? That is an example of a synchronous conversation. We've interacted with synchronous functions quite often up to this point. But now that we're working within a front-end module, starting yesterday when we were working with our script tags, we started working with asynchronous relationships. Now, asynchronous relationships differ from synchronous because there's multiple things happening at one time, all right? I like to use the example of washing laundry. At the same time, the laundry is being washed and you could be doing other chores, right? I'm not going to stand there and stare at my laundry machine until it's completely done washing my clothes before I start doing anything else. I'm actively doing other functions around my house, whether it's cleaning or coding or just living my life while my washer is actually washing my clothes, right? This is asynchronous functionality. Now, our JavaScript here is an asynchronous function. Notice how we are pausing JavaScript and we're telling JavaScript, hey, you need to wait. That doesn't mean that it never rendered the rest of my HTML, right? Everything was still rendered. And if I have some sort of console.log trigger or other functionality going on in the background, such as managing the DOM or interacting in other events, those events would work at the same time that my request is being generated and that my promise is being resolved. So anytime you are making a request, you are making an asynchronous function. So request generate asynchronous functions. All right, does anyone have any questions over why this get Pokemon data is an asynchronous function? All right, doesn't seem like we have any questions. Now, this is a common standard for being able to write asynchronous functions and making requests, but there is a more modern way of being able to write requests. We are specifically teaching you both ways of making these requests because there is a good chance that you will interact with both methods in a professional environment. So let's go ahead and dive into it. The concepts are going to stay the same. So I'm going to copy it, and then I'm going to paste it. All right. So the concepts of get Pokemon data are going to remain the same. We're going to make a request. We're then going to handle the body of that request and send back a response. But now in JS6, we actually have something called async and await. When you establish an asynchronous request, you no longer have to utilize .then or .catch. All right, now what we can do is say, hey, I have a response that's going to be generated once this promise is resolved. We're still telling JS you need to wait. In this case, we're doing it by calling the await keyword. All right, a response will come back, and I could generate my data from said response. If I want to have a try and catch block still, I can do so as such. I can try to send a request. What is happening here? I will then catch my error. And then console.error the error and alert that Pokemon doesn't exist. All right, there's no .then because .then is being managed by await. Both of these are asynchronous functions. They're just different syntax. They're accomplishing the same exact goal. Here we're waiting for the response to be resolved, and we're storing that resolve value inside of the variable response. Down below, in this function here, I'll comment it out here shortly. We're waiting for the response to be resolved in .then, and then we're passing the resolved value of that promise into a parameter named response. All right, both functions work exactly the same. It's just different syntactical sugar. As far as benefits over one another, something that's really beneficial about this get Pokemon data is that you have complete control over each step of the request, whereas the method of async and await, you don't have complete control of each portion of the request. You're just waiting until the request is completed. When you utilize this .get and .then, there's a .then, .catch, and .finally. Those are the three separate stages that you can utilize, all of which are unavailable if you use async and await. let's try it out. Let's make sure that this works properly. And I'm going to refresh my page. Let's grab Pikachu. Pikachu still works. Let's grab Bulbasaur. And Bulbasaur still works. All right. At this point, does anyone have any questions over how asynchronous functions work, how we're making requests with Axios, or any of the topics that we covered in part 2 of our lecture? All right, it doesn't seem like we have any questions. I do have one more thing that I would like to cover really quick. This is additional from part 1 of our lecture. We never finished how to actually set this up inside of Docker. So let's go ahead and do that really quick. So first, whenever we're working with this, we have to realize that Docker is working within a Docker network. So creating the Docker file itself is actually pretty similar to what we've seen before, right? The Docker file, we would just specify, hey, I want to utilize a node version. The node version that I want to use is 18, or we could say latest if we wanted to. From there, I want to create a working directory where that working directory is of app. We've seen all of this before. I want to copy everything into this working directory, and I want to install my project. So I can say run npm install. From there, I'm going to expose a specific port, and this is new. We haven't seen this exposed portion before. When I run npm run dev, we see that run dev, and let me run it again. That's going to be easier. When I run dev, it's being used inside of 5173. Now, this is inside of my Docker network. So I actually have to expose said file or expose said port so I could tie it to my machine's port for 5173. So I'm going to expose 5173. And then finally, I'm going to utilize the command stating npm run dev. Now, here's something important that we also have to talk about. When I run npm run dev, I'm seeing this localhost at 5173. But notice it's telling me that it's local. When we talked about Docker, we described Docker as a machine with containers inside of it, where the network is the upper layer and local is the lower layer. Here it's telling me that if I want to utilize network collection, I have to use dash dash host as well. All right. So if I have to use dash dash host as well, where do I add that? I actually have to go into my scripts in package.json. And this dev, I'm going to go ahead and add dash dash host. Finally, we go into how to run this Docker file. Well, the building process should be easy, right? And I'm just going to put it in the script. That way you all have access to it inside of demos and notes, and you don't have to remember this off the top of your head, right? In the script, I can run docker build. In this case, I want to build my image of React image within this context. And then finally, I want to run my container. So I'm going to docker run, and there's a couple of flags that we haven't seen before that we're about to go into right now. There's dash dash RM flag, where the dash dash RM flag stands for please remove as soon as completion is over. There's the port flag, which is going to tie port 5173. And I'm going to do a review over this for stand down because I know I'm going over this rather quickly. And I would like to spend some more time talking about this. So please know that we will run a quick review over this later on. All right, so it's going to tie our ports to 5173. This is my machine's port. to the Docker network port 5173. We're then going to utilize something called volumes, where the volume is going to tie my current working directory to the app within my Docker network. Finally, we can run a name, calling this the React container. And we could build my actual image, which in this case we called it my React image. So now I can go ahead and execute run container. You can see that's building my image. Okay, I would like to allow that. It's copying everything in there. There you can see it installing. Okay, so it seems to have run into an error. Let's see. Throw error, cannot find module, app, npm run dev. All right. I'll go ahead and cover this later on when we do our review. I am out of time, and I'm sure we've covered too much information at this point to be able to debug this and continue on. So let me go ahead and stop our recording here.